glasses of water. One is at about room temperature, at about 80 degrees Fahrenheit, and the other is about 180 degrees Fahrenheit. Which one will freeze first if we put them into the freezer?
Okay, so here we have the 2 glasses of water. Earlier we took the temperatures of both, and this one was at a higher temperature and this one was at a lower temperature. So when we put them outside to freeze, this one took longer to freeze because it was already at a higher temperature and basically had to make up the difference, become the same temperature as this glass of water and then freeze over. So as you can see, this one is not as frozen, and then this one is clearly a solid and is not breaking at all. And that's what we have.
Show you guys an experiment. We're going to take the temperature. We have 3 glasses here. One which is at 50 degrees Celsius Fahrenheit. One at 80 degrees Fahrenheit. And the other is at 170 degrees Fahrenheit. And which one do you think will freeze first?
We brought our water outside now. We've got our room temperature water, boiling water, and our cold water. So we're going to throw them up in the air and see which one freezes.
Oh my God! You see that? You see that?
Now that Travis just made me look like a fool, proving that warm water can freeze faster than cold water, I decided to do a little bit of research to try and figure out why exactly that happens. And scientists basically have 2 schools of thought on this, and that's why they call it the X factor, because they're not exactly sure why it happens. One reason they think is that because cold water is more viscous, or when something's more viscous, it's less willing to flow. It doesn't break apart as much as the hot water does when you throw it up in the air, and since the hot water breaks up more, that the smaller pieces of hot water have a better surface area to volume ratio, so that contact with the air can allow them to freeze quicker. But we sympathize more with the second view of the scientists, so let me step over to my board and show you guys what that is. So this should look pretty familiar to you guys. This is the vapor pressure to temperature graph we had in our mixing clouds packet, and this kind of explains a little bit what happened with the boiling water. When you throw that boiling water up in the air, its high temperature that it has and the low dew point of the air creates that high net evaporation that we have, and since that makes the dew point right around the droplets go up pretty high, we have this right here, and since we have that low temperature right here, we're going to get that high amount of condensation that you see, and then that condensation kind of creates a mixing cloud, and those small little water droplets can freeze so quickly because they're so tiny, and that's what creates that almost a frozen cloud type fog that you guys just saw outside.